From a distance, Jupiter looks almost gentle. Soft bands of orange and cream swirling gracefully across a giant sphere, a single red eye staring back at us from the clouds. It looks like a painting. It is not a painting. Beneath those calm-looking bands is the most violent, most energetic, most punishing environment of any planet in our solar system. A world of storms larger than entire continents, radiation intense enough to fry a spacecraft's electronics in hours, and a magnetic field so massive it would appear larger than the full moon in our sky if we could actually see it. Jupiter isn't peaceful. It never has been. Tonight, we're looking at what NASA's Juno spacecraft has actually found, lurking beneath Jupiter's calm exterior, and why the more scientists study this planet up close, the more its beauty starts to look like a disguise. To understand why Jupiter deserves its reputation, you first have to understand the scale of what you're actually looking at. Jupiter is the largest planet in the solar system, so massive that more than 1,300 Earths could fit inside it, and so gravitationally dominant that it influences the orbits of nearly everything else in the solar system, including comets and asteroids that pass anywhere near it. It has no solid surface to stand on. What you're seeing in every photograph is the top of an atmosphere that simply keeps getting denser and denser the deeper you go, transitioning gradually into layers of liquid hydrogen, then a strange metallic hydrogen ocean, unlike anything found naturally on Earth, wrapped around a core that scientists are still working to fully understand. There's nowhere to land. There's nowhere to stand. There's only atmosphere all the way down, and that atmosphere is doing things that would be instantly fatal to any spacecraft or person unlucky enough to get close. That absence of a surface changes everything about how you have to think about this planet. On Earth, weather is something that happens to us, a layer of turbulence sitting on top of solid ground we can retreat beneath or shelter from. On Jupiter, there is no beneath. The storms aren't happening on the planet. In a very real sense, they are the planet, at least as far as anything we could ever hope to observe directly. Descend far enough into Jupiter's atmosphere and the pressure alone would crush a spacecraft long before you ever reached anything resembling solid ground, all while punishing wind and turbulence tear at it from every direction the whole way down. NASA's Juno spacecraft, which has been orbiting Jupiter since 2016, was built specifically to survive this environment and study it directly, and what it's found over its extended mission reads less like planetary science and more like a catalog of natural disasters happening simultaneously, permanently, all over the same world. As Scott Bolton, Juno's principal investigator at the Southwest Research Institute, put it plainly, everything about Jupiter is extreme. The planet hosts polar cyclones larger than Australia, violent jet streams, the most volcanic body in the entire solar system. Orbiting nearby, the most powerful aurora of any planet, and the harshest radiation belts humanity has ever attempted to fly a spacecraft through. Let's start at the poles, because that's where some of Juno's most unsettling imagery comes from. Unlike Earth, where hurricanes form individually and drift across oceans before dissipating, Jupiter's poles are permanently crowded with enormous, long-lived cyclones locked into strange, stable geometric formations. The North Pole hosts 8 massive cyclones arranged in an octagonal pattern around a ninth storm sitting directly at the pole itself. The South Pole hosts a similar arrangement of 5 cyclones circling a central storm. Each of these storms is roughly the size of Australia or larger, and unlike hurricanes on Earth, they don't dissipate after a few weeks. They've persisted for years, locked in a slow rotating standoff with their neighbors, close enough to each other that their outer edges nearly touch, yet somehow never merging or drifting apart entirely. Scientists still don't fully understand what keeps this bizarre formation stable, or what would happen if it ever broke down. Juno scientists have spent years simply tracking how these storms move, and even that turned out to be stranger than expected. Using years of accumulated imagery from Juno's camera and infrared instrument, researchers discovered that each cyclone in these polar formations slowly drifts even closer to the pole over time, a process called beta drift, driven by the interaction between Jupiter's rotation and each storm's own circular wind. Pattern. It's a reminder that even something as seemingly stable as this geometric cluster of storms is quietly, continuously shifting, evolving on timescales long enough that it took a spacecraft orbiting for years to even notice the movement at all. Then there's the storm most people already know by name, the Great Red Spot, Jupiter's iconic swirling eye has been raging continuously for at least the better part of 2 centuries, and quite possibly far longer. For most of that time, we only knew what it looked like from the outside, a churning oval of reddish clouds visible even through backyard telescopes. Juno changed that. Using its microwave radiometer to peer beneath the visible cloud tops, scientists determined that the Great Red Spot doesn't just sit on the surface. It plunges roughly 300 miles down into Jupiter's atmosphere, a storm system with genuine depth and structure extending far below anything visible light could ever show us. Wind speeds inside the storm's outer bands have been measured reaching several hundred miles per hour, fast enough to tear apart most structures ever built on Earth, sustained continuously for centuries, with no sign of stopping. And that's just the storms we can see. Juno's radio occultation experiments, in which signals sent between the spacecraft and Earth pass directly through Jupiter's atmosphere and get bent by its temperature and density, have revealed jet streams racing around the planet at speeds exceeding 200 miles per hour, extending far deeper into the atmosphere than scientists originally expected. These aren't storms confined to a thin surface layer, the way weather stays largely confined to Earth's lower atmosphere. On Jupiter, the turbulence goes deep, reaching hundreds of miles beneath the cloud tops. Driven by processes scientists are still working to fully map. If the storms weren't enough, Jupiter's magnetic field adds an entirely different kind of danger. It is, by a wide margin, the most powerful planetary magnetic field in the solar system, generated deep within that strange layer of metallic hydrogen, acting almost like a planet-sized dynamo. That magnetic field doesn't just sit quietly around the planet, it traps and accelerates charged particles into radiation belts so intense that Bolton himself has described flying through them as, in his own words, a little scary, despite Juno having been specifically engineered with a titanium vault to shield its electronics from exactly this kind of punishment. Every close pass Juno makes through these radiation belts pushes the spacecraft through conditions far harsher than anything encountered anywhere else in our solar system. Conditions that would destroy an unshielded spacecraft's electronics within a matter of hours. That magnetic field extends so far into space that if it were somehow visible to the naked eye from Earth, it would appear larger in our sky than the full moon, despite Jupiter itself sitting hundreds of millions of miles farther away. It forms the largest coherent structure in the entire solar system, aside from the sun's own heliosphere, an invisible, sprawling region of trapped, accelerated particles extending millions of miles beyond the planet's visible cloud tops in every direction. Spacecraft engineers don't just design around this field once and move on. Every extension of Juno's mission has meant deliberately routing the spacecraft through more of this punishing environment, trading additional radiation exposure for the chance to gather more data before the spacecraft's electronics eventually succumb to the accumulated damage. That same magnetic field is also responsible for Jupiter's aurora, the most powerful light show of any planet in the solar system, permanently glowing at Jupiter's poles as charged particles slam into its atmosphere. Unlike Earth's aurora, which flares up occasionally and fades, Jupiter's aurora is essentially always on, continuously fed by a combination of the solar wind and, remarkably, volcanic material launched into space by one of Jupiter's own moons. That moon is Io, and it might be the single most violent object anywhere near Jupiter. Io is the most volcanically active body anywhere in the solar system, constantly reshaping its own surface with rivers of lava and towering plumes of ash and gas, driven not by any internal radioactive heat source, but by the sheer gravitational stress of orbiting so close to a planet as massive as Jupiter. As Io gets pulled and squeezed by Jupiter's gravity during every orbit, that friction generates enough internal heat to keep the moon in a state of near constant eruption. Juno's most recent flybys, including close passes in December 2024 and again in May 2025, captured a massive, ongoing eruption still actively spewing lava and ash months after it first began, and it used infrared mapping to build the first detailed picture of the temperatures hiding just beneath Io's scorched surface. Some of that volcanic material doesn't stay on Io at all. It gets stripped away by Jupiter's overwhelming gravity and magnetic field, feeding directly into the radiation belts and aurora surrounding the planet itself, meaning Jupiter isn't just violent on its own. It's actively feeding off the violence of the moon orbiting closest to it. It's a genuinely strange relationship when you sit with it. Io doesn't just happen to orbit a violent planet. Its own violence is a direct consequence of that planet's gravity, and the material it spews out doesn't simply drift away into space and disappear. It gets captured, accelerated, and recycled back into the very radiation environment threatening every spacecraft that dares to approach. Jupiter and Io aren't two separate hazards sitting near each other. They're locked in a feedback loop, each one intensifying the danger posed by the other, a genuinely unique arrangement that doesn't have a clean parallel anywhere else in the solar system. Put all of that together, and Jupiter starts to look less like the calm, decorative giant it appears to be in photographs and more like a genuinely hostile environment. One where storms the size of continents lock into permanent standoffs at the poles, where a single storm has raged continuously for centuries and plunges hundreds of miles into the planet, where jet streams roar past at highway-defying speeds hundreds of miles. Beneath the clouds, and where the space immediately surrounding the planet is saturated with radiation intense enough to threaten even a spacecraft specifically engineered to survive it. Nothing about Jupiter, once you look past the surface, is calm. And Juno isn't finished. With its mission extended and more close flybys planned, scientists expect the discoveries to keep coming, each new orbit offering what Bolton has described as a fresh vantage point on a planet whose orbit-altering gravity, continuous storms, and punishing radiation environment make it unlike anything else humanity has ever sent a spacecraft to study up close. Every new pass through those radiation belts is, by the mission's own principal investigator's admission, still genuinely unsettling, even for the team that built the spacecraft specifically to survive it. So the next time you see a beautiful photograph of Jupiter's swirling orange bands, remember what's actually happening beneath that calm-looking surface. Storms, the size of continents, locked in an unexplained standoff at each pole. A single hurricane, older than most nations on Earth, reaching down 300 miles into the planet's depths. Radiation so intense, it terrifies the engineers who built a spacecraft specifically to survive it, and a nearby moon torn apart by gravity itself, constantly erupting, feeding its own violence directly back into the planet that tortures it. Jupiter isn't the calm giant watching over our solar system. It's the most relentlessly violent world we've ever had the courage to fly a spacecraft into, and every new orbit only seems to confirm just how little of that violence we've actually managed to fully understand. If you want to be here for whatever Juno finds on its next close pass through Jupiter's radiation belts, subscribe and turn on notifications, because the more we look at this planet, the less peaceful it turns out to be.